quantum computing PASQALs technology. Few would argue that France is one of the leading pioneers of quantum technology on Earth. In addition to his thriving quantum startup ecosystem that Muquans has developed since it was founded more than a decade ago, France can also rely on well-funded national initiatives. The French National Center for Scientific Research and the Pac Quantique (PAQ) are prime examples. Quantum Intelligence Platform, with 37 quantum startups and companies in the country, all at different stages of development and dealing with quantum technology. Pure quantum companies like Alice and Bob, NextGenQ, Quandela and Qubit Pharmaceuticals are proof that things are going in the right direction. Another fast-growing company in space is PASQAL, a startup that is developing quantum computers using arrays of neutral atoms. PASQAL's quantum computing background. Based in Palaiseau at the outskirts of Paris, PASQAL changed into based as a spin-off from Institut d'Optique in 2019 with the aid of using Georges Olivier Raymond, Christophe Urchak, Dr. Antoine Broes, Dr. Thierry Lehay, and, watch for it, Professor Dr. Alain Aspect, these days offered the 2022 Nobel Prize in Physics along John F. Clauser and Anton Zeilinger for experiments with entangled photons, setting up the violation of Bell's inequalities and pioneering quantum facts science. PASQAL's core quantum technology. PASQAL's IP, as already mentioned, became in the beginning primarily based totally at the paintings of Antoine Broes and Thierry Lehay at Institut d'Optique, IOGS, CNRS, in which they validated the simulation of many frame troubles intractable for classical high-performance computers, HPCs. In comparison to different qubit modalities, the startup's impartial atom tool approach can attain quantum registers with a bigger quantity of qubits and better connectivity with relative ease, consistent with PASQAL. So why, then, aside from the large quantity of qubits and the better connectivity, are impartial atoms so promising for quantum computing's future? The magic sauce is that qubits crafted from impartial atoms are rather nicely remoted from outside noise, which means their encoded country stays unbroken. Another gain is it's miles less difficult to govern those sorts of qubits, the usage of what's called optical traps, or optical tweezers. This is in which a laser beam is carried out to permit gadgets to be picked up and located in any other vicinity. The usage of lasers, allowing scientists to scale the quantity of bits inside a system. PASQAL's quantum products. At the heart of PASQAL's technology are programmable quantum simulators and quantum computers built from 2D and 3D atomic arrays. Apart from these products, PASQAL also develops lasers, vacuum technology, electronic controls and a proprietary software stack. This will be extended by a merger with Chu & Company, giving PASQAL access to a leading quantum algorithm portfolio, made by quantum programmers all over the world. PASQAL's Quantum Processing Unit, QPU, uses Pulsar, an open-source neutral atom framework, to program the system with a train of laser pulses. PASQAL's most significant developed patents. In addition to a significant IP and patent portfolio in the field of neutral atomic quantum computing, PASQAL has made significant strides, building a sizable portfolio of algorithmic patents in his 4 categories of quantum algorithms. Hard optimization problems. It has long been known that quantum computers using neutral atoms are very good tools for solving Poe or Mies geometry optimization problems. In addition, PASQAL recently developed a quantum neural network approach for solving more general optimization problems. The method, called quantum extreme learning, was developed in collaboration with PASQAL client Johnson & Johnson. The two organizations have applied this method to molecular discovery and optimization problems. Solving differential equations. PASQAL has developed a whole family of proprietary algorithms aimed at solving different classes of differential equation problems. These range from solvers for highly nonlinear partial differential equations, to stochastic equations, applied to generate time series data, to integral differential equations. The Z you want to solve is unknown, but some measured/market data are available, and solutions. Design optimization problem, combined regression and optimization. These algorithms are currently available in real-world applications such as weather modeling, using BASF, material deformation, BMW, aerodynamics, Airbus, Multiphysics Simulation, LG, Engineering, Siemens, and Computational Finance, unknown client. Graph-based machine learning. PASQAL has developed a unique method to solve graph core machine learning problems and recently demonstrated how to apply this method to predict the toxicity of molecules based on their structure. The algorithm, called the quantum evolution kernel, can be natively, and efficiently, implemented on PASQAL hardware operating in analog mode, making it a strong candidate for early quantum supremacy. Hamiltonian simulation. PASQAL co-founder Professor Antoine Brois has demonstrated that quantum computers of the type provided by PASQAL can produce results that exceed those achievable with conventional computers, so-called quantum supremacy. This experimental result was obtained in Hamilton's field of simulation and has interesting applications, for example in condensed matter physics, quantum magnetism and superconductivity research. Who are PASQAL's main competitors? To do this, relying on a quantum intelligence platform to provide relevant data, and through a wide range of well-constructed taxonomies, PASQAL's competitors can use neutral atom alignment or similar techniques to create quantum. It turns out that you are building a computer. 1. COLDQUANTA. Founded in 2007, COLDQUANTA is building scalable and versatile cold atom technology used by world-class organizations around the world. Used by NASA on the International Space Station. COLDQUANTA uses quantum mechanics to build and integrate various quantum computers, sensors and cold atom networks. From fundamental physics to cutting-edge commercial products, COLDQUANTA enables quantum everywhere through an ecosystem of devices and platforms. His cold as atom method can be adapted for multiple applications across the quantum ecosystem. The company is currently building 2 quantum information platforms that can be accessed via the cloud. In terms of locations, COLDQUANTA is headquartered in Boulder, Colorado, with offices in Madison, Wisconsin, and Oxford, UK. 2. Atom computing. Based in Berkeley, California, Atom Computing was founded in 2018 by Benjamin Bloom and Jonathan King with $5 million in seed funding. His goal is to go from nuclear spin bits made of neutral atoms, which provide a more stable platform for performing accurate error correction, to the world's most scalable and reliable bits using neutral atoms, building a high quantum computer. A key to atom computing's approach is the development of a flexible platform that supports a universal set of quantum gates and allows developers to formulate different quantum algorithms that can be applied to different use cases. All of these important milestones were reached in September 2022 when Atom Computing opened its largest R&D facility in Boulder, Colorado. 3. QUERA Computing. Founded in 2018 by Mikhail Lukin, Marcus Grenner, Vladin Valetic, Dirk Englund, and Nathan Gemilk, QUERA Computing is a neutral atom-based quantum computing startup based in Boston near Harvard University. The company is based on groundbreaking research recently conducted at Harvard and MIT. QUERA's mission is to build the industry's most scalable quantum computer to address useful but classically unsolvable problems in commercially relevant applications such as optimization, simulation, materials science, and pharmaceuticals. How is PASQAL funded? To do this, PASQAL harnessed the power of its data platform to record PASQAL's fundraising history from the start. As an aside, Chu & Co., the company his PASQAL merged with in the first quarter of this year, had raised a similar amount prior to the merger, with a 2020 seed round led by Briga to bring his 330. Had raised millions of dollars. Together, Briga rejoined his $29.7 million Series A in March 2022, which included P France, Alaya Partners and Supernova Invest. Who are PASQAL's most significant quantum customers? This is where things get interesting because PASQAL boasts a client/partnership list that includes Airbus, pharmaceutical giants Johnson & Johnson, LG, Thales, EDF, BMW Group, Cinica, and Crédit Agricole. The last 2 companies, Cinica and Crédit Agricole, were the first 2 of his customers to take advantage of his PASQAL cloud service in private beta. At Cinica, an Italian consortium of universities operating one of the world's most prestigious supercomputing centers, several member universities are developing demonstration systems that integrate traditional HPC capabilities. It definitely uses Pascal's quantum system as a coprocessor. In contrast, CACIB, the corporate and investment banking arm of the Crédit Agricole Group and the 12th largest banking group in the world by Tier 1 capital, uses Pascal intellectual property to ensure that quantum algorithms are at risk. We are researching how we can provide a competitive edge in management in the market. Strategies can earn attitudes in the capital markets. Pascal's quantum partnerships. Apart from the corporate partnerships in the previous section, Pascal has worked or is working with several commercial and academic institutions. 1. CENTRALESUPÉLEC. PASQALs, France's leading engineering school at the University of Paris-Saclay, GIF-Servet, France, has established an academic partnership with CENTRALESUPÉLEC to provide students with valuable know-how and to meet the expectations of stakeholders. Purpose: to meet the quantum market. 2. Siemens. A partnership between PASQAL and Siemens, a German multinational conglomerate and Europe's largest industrial manufacturing company, explores quantum applications in computer-aided design, simulation and test. 3. MBDA. European multinational missile designer and manufacturer MBDA has announced a partnership to develop a quantum defense optimization approach to run on Pascal's quantum computer. 4. BASF. The world's largest chemical company uses Pascal's quantum processor to predict weather patterns. 5. PARITYQC. As Austrian QC startups, the two companies have decided to combine their efforts to implement a PARITYQC architecture that is particularly suitable for the atomic neutral platform PASQAL. Industrial applications solve the case. 6. NVIDIA. Pascal's collaboration with NVIDIA, a US-based software and fabless company that develops graphics processing units, GPUs, application programming interfaces, APIs, for data science and high-performance computing, and system-on-chip units has been announced. In 2021, he plans to expand his solution portfolio by establishing a quantum computing center of excellence with a cluster of 10 of his NVIDIA DGX A100 systems with NVIDIA InfiniBand networks. Pascal's quantum computing key takeaways. Like atom computing and COLDQUANTA, Pascal is well on its way to achieving its goals. Our knowledgeable team, led by founders, including Nobel laureates, experienced in both the research and commercial aspects of the industry, have come a long way.